Welcome to Rama Science World. My dear students, today we will discuss about some important topics in physics. So that is Newton's law of gravitation. Next one, relation between small g and capital G. Next, variation of small g with increasing and decreasing heights above the ground. Variation of small g with increasing and decreasing with the depth of the ground. These topics we will discuss now. First, Newton's law of gravitation. Newton's law of gravitation tells every object in the universe attract another body with some amount of force F. See, this is a body. We take another body here. So mass M, here mass M2. So like every body in the universe attract another bodies with some amount of force. This force is directly proportional to product of their masses, and inversely proportional to square distance between them. So here we introduce a constant by removing proportionality. F equal to capital G into M1 M2 by R square. So this is the Newton's law of gravitation. So capital F equal to capital G M1 M2 by R square. So here capital G is a gravitational constant. Capital G means gravitational constant. The value of gravitational constant 6.67 into 10 to the power of minus 11 Newton meter square by kg square. So 6.67 into 10 to the power minus 11 Newton meter square kg square. This is the value. This is the value constant wherever you go. Does not change. So here, suppose we take two bodies. One body is the earth. Another body is an object on the earth. In this case, gravitational force. See here, mass of the earth is capital M and mass of the object is small m. So here the attractive force F equal to capital G, capital M, small m by R square. See, F equal to capital G, capital M, small m by R square. Here capital M means mass of the earth, small m means mass of the object. So R is the radius of the earth. See, so once again we repeat the concept. Newton's law of gravitation. Every object in the universe attract another objects with some amount of force. This force is directly proportional to product of their masses and inversely proportional to square of distance between them. and the force act along the line joining between them. So this is the Newton's law of gravitation. G equal to 6.67 into 10 to the power minus 11 Newton meter square per kg squared. So in case we take the two objects, one object is we consider an object mass m on the earth. In that case, gravitational force equal to F equal to capital G, capital M, small m by r square. Okay, now we discuss about relation between small g and capital G. Already we learned F as for the Newton's law of gravitation, capital F equal to capital G, capital M, small m by r square. So now already you know that weight. What is the weight? Weight of an object means, so the force on the body towards center of earth. The force on the body towards center of earth. So the force act on the body towards center of earth is called weight. It is a force. So already we know that F equal to mg. From these two equations, by equating with these two equations, mg equal to capital G, capital M, small m by r square. Small m cancel. So the relation between the small g and capital G equal to. So this is the relation between the small g and capital G. G is equal to, small g equal to capital G, capital M by r square. So what is the small g? Small g means acceleration due to gravity. So the acceleration is generated due to the gravitational force, that is small g. Now we discuss about variation of small g with height. See, we consider a body of mass m at a height h above the ground. In this case, the relation, generally, suppose a body on the ground, in that case small g, the relation between small g and capital G is small g equal to capital G m by r square. Already we know that. So suppose a body at a height h above the ground, in that case gh is equal to capital G, capital M by r plus h whole square, because this is the height and this is the radius of curvature, radius of the earth. gh is equal to capital G, capital M by, we can write like this. See, capital G, capital M by r square means g. So we move upside. H plus 1 plus h by r power minus 2. So we can write like this. Small g into, here binomial theorem, as for the binomial theorem, 1 minus 2h by r. So this is the relation. So gh is equal to g into 1 minus 2h by r. Here gh equal to g into 1 minus 2h by r. The value of g is increasing or decreasing, depends on the height. See, the value of g is decreasing by increasing the height. If you move away from the ground, the value of g is decreasing. Here decreasing. Suppose if you take the fraction delta g means gh, here g minus gh. So from this formula we can write delta G is equal to G into 2h by R. The fraction delta G by G equal to 2h by R. This is the fraction of the gravitational acceleration, 2h by R. Okay, now variation of G with depth. Variation of G with depth. Suppose already we know that the relation between small g and capital G. What is that? Capital G, small g equal to capital G, capital M by R square. So this is a relation, already you know. Suppose if you move down to the ground. So in this case, this is the R, actually the radius of Earth. If you move down a depth of the ground, so this is the depth. So remaining here R minus D. In that place, what is the acceleration due to gravity? Here we already know that density equal to mass per volume. Here this is the sphere. So the mass equal to density into volume. Density, volume means 4 by 3rd pi r cube. Substitute the formula in this case. Capital G, small g equal to capital G, capital M means 4 by 3rd pi rho r cube by r square. Here r square, here r cube, cancel it. Small g equal to capital G 4 by 3rd pi rho r. But in this case what happened? So if you move depth, if you move to the down of the ground, so what happened? GD equal to 4 by 3rd pi g rho r minus d. If you take the common 4 by 3rd pi g rho r 1 minus d by r. So here this value and this value same. That's why GD equal to G into 1 minus d by r. This equation shows the variation of G with the depth. So what is the G value? If you move to the down means G value decreases. G value decreases. Here the fraction of acceleration due to gravity delta G by G equal to delta G by G equal to d by r. So already this is the acceleration due to gravity if you move depth of the ground. So the value of G is decreasing if you move depth of the ground. Okay, once again I repeat, I conclude all the what we learned today. So first of all, from the Newton's gravitational law of gravitation, this is the formula for the law of gravitation. Capital G equal to capital F equal to capital G m1 m2 by r square. So this is the relation between the small g and capital G. Small g equal to capital G capital M by r square. Next one, the variation of G with the height. So GH is equal to G into 1 minus 2h by r. So fourth one, GD equal to G into 1 minus d by r. The value of gravitational acceleration, the value of gravitational acceleration is decreasing above if you move above the ground by increasing the height. Decreases, or if you move down to the ground, or if you move to depth of the ground, if you move more depth, a value of G also decreasing. decrease. At the center of the earth, the value of gravitational due to gravity value 0. So on the earth, G equal to 9 meter per second square. This is a topic about this is the information about the gravitational acceleration and the Newton laws of gravitation. Thank you very much.